Figure below shows the design of a circular stained glass panel on display at Hopewell's Antique Shop. Seams separate the pieces of the panel. All red triangular pieces shown are congruent and have a common vertex with each adjoining triangular piece. The two squares shown are inscribed in the circle. That means drawn inside the circle. Inscribed means drawn inside. The diameter of the panel is 2 feet. The design of the stained glass panel has how many lines of symmetry in the plane of the panel? So a line of symmetry is a line drawn and it separates it equally. So we'll just see here how many lines of symmetry. There's 1, 2, 3, 4, 5, 6, 7, and 8. Those are the lines that separate that equally. 8 lines of symmetry, letter H. Same description, same picture, different question. This time, what is the area of the stained glass panel to the nearest 0.1 square foot? So to the nearest tenth of a square foot. Well, to find the area of a circle is pi r squared. The radius on this circle, since the diameter is all the way across the circle, the radius is halfway across the circle, therefore the radius would be 1. So the radius is 1. Pi, of course, is 3.14. So pi r squared to be 3.14 times 1 squared. And 1 squared, of course, is 1. 3.14 times 1, that is 3.14. You look at the answer choices, 3.14 is not showing up, but remember, it's to the nearest tenth of a square foot. So 3.14 to the nearest tenth is 3.1, which happens to be letter A. Same description, same picture, and for the third time, different question here. Kaya wants to install a new circular stained glass window in her living room. The design of the window will be identical to that of the panel. The diameter of the new window will be 75% longer than the diameter of the panel. The new window will be how many feet in diameter? So you're looking for the new diameter of the window in feet. The current diameter right now, of course, is 2 feet. That's from the drawing. You need to find 75% of that. So finding 75% of 2, you can do whatever you want, but I would multiply 2 by 0.75, and that will give you 75% of 2, which is 1.5. So 75% is 1.5 feet. We're going to add that 75% onto the 2 feet, because it says the diameter of the new window will be 75% longer than the diameter of the panel. So add that 75% onto the 2. 2 plus 1.5, that is 3.5, and that is letter J. In the figure below, segment AB is parallel to segment CD. So this AB is parallel to CD. Segment AE bisects angle BAC. So this big angle BAC is cut in half by segment AE. Bisect means to cut in half. And CE bisects angle ACD. So this big angle ACD is cut in half by this segment CE. If the measure of angle BAC is 82, so you're told that this big angle measurement BAC is 82. What is the measure of angle AEC? So you need to find this measurement AEC. Angle AEC, that's what you're looking for. You have to work your way around to find that. You're told that angle BAC is 82. You're also told that AE bisects or cuts that big angle in half. So if that's the case, then this angle CAE is 41. It's half of 82. Also, angle ACD here is 98 because angle BAC and ACD, those are what are called same side interior angles. With respect to the parallel lines, they're on the same side of the transversal, with the transversal being AC here. They're on the same side of the transversal, so on the right side of the transversal, and on the inside or interior of those parallel lines. Those are called same side interior angles. Same side of the transversal on the inside of the parallel lines. So if this big angle BAC up here is 82, then this angle ACD is 98 because those same side interior angles add up to 180 degrees. So take 180 minus 82, that's how we're getting this angle ACD to be 98 right there. Remember that big angle ACD of 98 is cut in half by CE. So if that big angle is 98, then half of it would be 49. So angle ACE is 49. Now you know 2 angles of that triangle. Knowing 2 angles of that triangle, you can get the third angle, which is the one you're after, angle AEC. So if that angle is 41, that angle is 49, add those together and subtract from 180, that'll give you this missing angle, the one you're looking for, which happens to be 90 degrees. and that is letter C. In the circle shown below, chords TR and QS intersect at P. So TR and QS, you can see there in the drawing, they intersect at P, which is the center of the circle. And the measure of angle PST is 30 degrees, and that's given to you, shown there in the drawing. Angle PST is 30 degrees. What is the degree measure of minor arc RS? So right there where the question mark is, that's what you're finding. So you have to work your way around in order to find that with what you know. The measure of an inscribed angle of a circle is half the measure of its intercepted arc. That's a rule from geometry that you're just going to have to remember to get this right. So the measure of an inscribed angle, that means drawn inside of a circle, is half the measure of its intercepted arc. So that angle 30 degrees there is half the measure of its intercepted arc, or half of 60. Another rule from geometry that you have to remember, the degree measure of minor arc is equal to the degree measure of its central angle. So this arc right here is 60 degrees is equal to that central angle measurement of 60 degrees as well. Remember, we're working our way around to find this measurement of arc RS. So we know this is 60, we now know this is 60, and right across from each other, those two angles are called vertical angles. Vertical angles are equal, so if that's 60, the one right next to it or across from it is 60 as well. And just like this rule over here, this rule, it will apply to this situation right here. The central angle is going to be equal to that arc. So that central angle of 60 degrees is equal to that arc of 60 degrees, and that's what we're looking for. RS is 60 degrees, letter H. For what value of A would the following system of equations have an infinite number of solutions? 2x minus y equals 8, 6x minus 3y equals 4a. Here you have a system of two linear equations. A linear equation is an equation that forms a straight line. And we're talking about them having an infinite number of solutions. So if you have a linear system or two straight lines, and you're talking about them having an infinite number of solutions, that means you're talking about them having an infinite number of intersecting points. A solution to a system is where the two graphs meet. So if you're looking for the value of A that makes those two equations have an infinite number of solutions, you're looking for the value of A that makes those two lines or those two equations the same. So 2x minus y equals 8, 6x minus 3y equals 4a. You could take that top equation. Remember, you can do anything to an equation you want to as long as you treat both sides equally. Well, if you'd multiply that top equation by 3, it's going to look very similar to that bottom equation. Because if you take 3 times 2x, that's 6x, and 3 times negative y is negative 3y. So we're taking that top equation, multiplying by 3, gets 6x minus 3y equals 24. Remember what we're after here. We're looking for the value of A that makes these two equations the same. So it's perfectly fair to multiply the top equation by 3. We have 6x minus 3y equals 24. And now we're wondering what value of A makes those two equations the same. Well, 4a in this equation matches up with 24 in this equation. So you could set 4a equal to 24 and then solve that for A. The value of A we're looking for that makes these two equations the same, or makes this system have an infinite number of solutions, is 6, letter B.